Okay, hello everyone. It's midday here in snowy Finland. Welcome to our quarterly Don't Fear the Fire webinar series. Today we have our first part of series focusing on railway. You may ask questions at any point of the presentation in the live Q&A chat. All questions are private by default and not visible to the rest of the audience. Just mention in the message if you want to discuss privately. At the end of the presentation, we will answer all the other questions. And of course, this recording is later available to every participant. After this webinar, you will know how you can improve fire protection without changing your composite. Also, you will know how our new fire test laboratory can help you achieve the required fire goals. And moreover, you will know what exciting new possibilities does this technology create. Okay. My name is Ari Hokkanen. I'm the founder and the CTO of the company. My background is in composites. I have studied composites, I have worked with composites, and I have had composites as a breakfast. Also, I think I might have some styrene in my blood. But I'm here with my colleague Trevor.
Good morning, everybody. I'm the technical business manager here at Finesta Coatings and worked in the coatings industry for the last 30 years.
Thanks, Trevor. A few words about us. We are ISO certified investor-backed SME from Finland. Our production and office facilities are located in Lahti, conveniently 1 hour from Helsinki Airport. Our products and methods are all our own technology. So, what do? We design, manufacture, and supply coatings. To be more specific, we design, manufacture, and supply coatings for composites. And to be even more precise, we design, manufacture, and supply fire protection coatings for composites by using 2 different technologies. The first one is innovative ceramification technique, where the polymeric material turns into ceramic material when exposed to the fire. And the second technology is so-called controlled intumescence, where the material starts to generate expanding foam when exposed to fire. So what do we see as a fire challenge in a composite market? Well, as you all know, composite materials are usually used as a last resort when the other materials fail. This is due to the great properties composites have, such as low density versus strength, appearance. We can have different colors and shapes, outdoor resistance combined with processability and consistent quality. However, as composites are made from oil, they burn easily, and this limits their usage in several applications where the fire is an issue. There are fire protected composites in the market, of course, but these are usually made fire protective by adding fillers in the resin, changing the resin to some other resin, less burnable resin. But this usually leads to the compromises in the composite properties, meaning that they are suddenly heavy, they are difficult to process because they have high viscosities, and you have limited colors available, and they cannot be used outdoors. And yes, you will get that fire protection element in some extent, but you will lose those great properties that composites was chosen in the beginning with. And we always say here that it's the same thing that you use the same tea bag for 5 times, you are technically still drinking tea, but it's not very good tea. So these are technically composites, yes, but they are not very great composites, but they have that fire protection element. So what is our solution? Our solution is to use fire protection coatings, which we sell under the trade name of RED. RED consists of 2 products. main products, the hybrid red, inorganic organic coating that gives that ceramifying effect, and the pure red, which gives that intumescent effect. So they work together. On the right side, you can see what red looks like, different colors and then very nice decorative properties. On the left side, you can see it's applied by common spraying tools. What this means in practice, it means that you can complete your composite by adding the missing fire protection element. You don't touch your composite, you keep your composite as it is, high quality, nice composite, you just paint it or coat it with our red system to get that fire protection element without losing the other property. Here we can see how the red actually works. How does it work on a composite substrate? We'll watch this video first full, and then we look at it again with some commentary. The 20-second video. Okay, let's watch it again. So what we have here, we have a high performance standard composite. This is a carbon fiber epoxy composite coated with a 2-layer system, pure red, hybrid red. So pure red underneath as a primary coat and a hybrid red as a top coat. And this it's a blue color where some water droplets are on the surface to give the nice effect. So the Bunsen burner is introduced on the right side. You barely see it, but it's still there, and it will increase the surface temperature rapidly. Bunsen burner comes, and let's take one step back. The Bunsen burner comes, and what happens next is, because it's inorganic organic system, so the organic material burns away, and that's completely fine. There's a small peak that the heat is generating, but that burns away in those temperatures, 300, 400, 500 temperatures. But when you continue burning, then all organics are gone, and the rest of the inorganic and the hybrid red has turned to the ceramic material. And what happens also in a controlled manner is that the heat is transferred from the ceramic material to the other side of the coating, and that will hit to the pure red layer, and that will start to expand, and that's why the bubble is formed. But instead of expanding too much, the ceramic shield is formed on the top of the intumescent layer, and that keeps the intumescent protected and not prevents it to fall on the floor. So in that controlled manner, we can introduce new way of protecting the composites without changing the composite. And even when you keep burning it, even on those temperatures above 1000, you can see it just goes red hot, and it's stable. It's stabilized in those temperatures, and you can burn it for a longer period of time. So this is the 2-coat system on the standard composite. Okay. So the question is, why to use coatings? Maybe it's not that common to use coatings in a composite business. Maybe gel coats are mainly used, but what are the benefits of the coating? It's the flexibility in composite production, of course. We will go more detail in these points, but that's the flexibility comes using coatings, different colors, different thicknesses, different methods. You can maintain and you can repair your composites. You can extend their life, and you can repair them before they are actually broken. You can have a full range of colors and texture effects. You have different gloss levels. You can have different colors in different places. You are very versatile on the decorative options. And also you can compensate some of the bad quality of the composite after demolding. Maybe there were some cracks on the gel coat, maybe there was some demolding pre-lease, and you can compensate, you can repair those afterwards with the coating. And now Trevor will continue from here. What's the additional benefits with red?
Thank you, Ari. So yes, with our red coating technology, we're able to also introduce some additional properties. So the red coating technology will give the fire protection we've just seen on the video, alongside all those above properties, and it's all in one. So effectively you can use red as your finishing coating system. You don't need to paint anything on top of red once it's been applied. It will give you that finished item, finished component performance. It gives you increased confidence in fire protection. So using a coating technology will ensure that you are meeting the requirements. We have many people on the webinar this morning in the railway industry, and that requirement is specifically the EN 45545 standard. And with the red coatings, you can boost your confidence. You can have confident results coming from using this coating technology. And as we say, you can use standard composites. You no longer have to use phenolic resins, or you have to play around with the composition of the composite, just putting the coating on top. So yeah, as we have said, certainly it's an alternative option to using phenolic resins. That seems to be the traditional way of meeting the fire regulations for composites in many industries. And of course, phenolic resins are not the easiest things to handle, and also have some issues with smoke and toxicity. So the red technology will enable you to replace those resins, removing fillers or veils. And of course, you can also use red on such technologies to boost levels and reach new levels of fire protection. So again, perhaps referring to the railway industry, if you have a hazard level 1 result at the moment, maybe using red, we can boost that to a hazard level 2, or maybe even a hazard level 3 result for you. It's an all-in-one system. So you get the solution to the fire protection. What we should say is the ceramifying layer, being predominantly inorganic in nature, gives excellent outdoor resistance. So inorganic chemistry will give you very good outdoor resistance, no yellowing, no problems with UV light exposure, and excellent water resistance. And we've done accelerated weathering tests to check this out. It will also give anti-graffiti properties and surface properties that will allow you to clean off graffiti and ensure that those damages are repaired easily. And of course, the finished component appearance is also fully flexible. You can get a full range of colors. We work with the RAL, the German RAL system for specifying industrial coating colors. You can choose your gloss, and also we can incorporate additives into the top layer of red so that you can have different surface textures. The other side of red is that it is boosting the confidence in terms of your fire testing performance. Many people in the composites world can get a good result on one day, and then they send it to another laboratory, or they send different test panels to another location and get a totally different result. We believe with these coating technology that you are going to be able to overcome those challenges of inconsistent results. Whether that inconsistency is from testing or from composite quality, you'll be able to overcome that with the red technology. And basically taking the impact of the composite out of the fire performance. So boosting your confidence in meeting the standards and overcoming concerns over inconsistent results. Red also brings you flexibility in the production of your composites. It is easily applied by standard methods, as Ari mentioned earlier. Spray application is our standard recommended process to give you the best control of film thickness and appearance, but it can also be applied by standard brush or roller application methods. It cures at room temperature, so if we're looking at certain composites and large size panels, for example, used in marine or in the construction industry, no need for a heat boost or curing mechanism. And also it brings some flexibility in terms of composite processes. So actually integrating the coating technology into existing composite production processes. We are selling, for one particular customer, we are selling our coating into a filament winding process, for example, where the red coating technology is incorporated inside the actual process, which obviously leads to cost savings and not requiring a separate coating step. Also, you have the flexibility in terms of items. So if you wanted just individual items coated, so you don't have to paint every bridge that you make, you don't have to paint every panel that you make the same color. You want some flexibility there, then obviously putting coatings on top of your composites gives you that, that facility. Coatings also are obviously highly useful in terms of maintaining and maintaining existing systems that have been installed. Certainly if you're offshore or if you're in hard to get to locations and you want to repair a damaged composite, so instead of dismantling the whole structure, you'll be able to use our red technology to patch up where damage has occurred. Depending on the level of the damage, we can give you full advice on what to use and how to use it. And you can also apply that on site under controlled conditions. If you have livery changes, color changes, for example, in the railway industry, a change of operators of the train and vehicles, then again applying our red technology over existing livery, existing materials is a possibility. We're just requiring standard preparation techniques for the surface, as used perhaps in the steel industry. Moving specifically on now to our focus for today's presentation, which is on rail. It's on railway and rolling stock and railway infrastructure. So the question is, where can our technology be used? Which areas in the rail sector can we be using these coatings? So far, we've done work with both thermosets and thermoplastics. The technology was developed specifically for thermosets, so for epoxy and for polyester, glass and carbon fiber type traditional composites. But we've also moved the work into thermoplastics now. So we're using red in both those, with both those types of materials now. We certainly have found that the red technology can be useful for decorating and protecting fire performance requirements for the rail vehicle exteriors. Often needing a three-coat system, you'll need a high gloss top coat, for example, and we have a red version of a high gloss top coat to achieve that. Rail vehicle interiors is obviously a big interest at the moment, trying to achieve the requirement set R1. And again, red is providing the answer for many applications there, and also in the rail infrastructure and the construction side of the rail industry. A little bit about the rules. We don't want to delve too deeply into these, but I'm sure that many on the call are aware of the rules. But the standard governing pretty much every requirement for railway vehicles with regards to fire performance in the rail industry is the EN 45545 Part 2 standard. This was phased in over a period of time over the last 10 years, but now all new rail vehicles in the EU must comply with these requirements. This standard is based on a list of different components, and so you have a list of applications, a list of components referred to as the requirement sets within the standard. And you can set different requirements, different levels of performance. And again, they've used the tag hazard level to indicate the severity of the performance that's required to be met in terms of fire. So the hazard levels 1, 2, and 3 are the ones that are referred to in the standard. Number 3 being the highest hazard level, the most challenging hazard level that would be required, for example, for trains that are going through long tunnels or for underground metro networks. The tests that are used within the standard are primarily ISO standards, a triple helping of ISO standards, the 5658, 5659 and 5660 standards, which measure 3 different aspects of fire and burning capability of the materials. And the key parameters really is something called the MAHE, the maximum average rate of heat emission, is a very key parameter in testing against this EN 45545 standard. We've actually circled on the right-hand side one of the clips from the standard in terms of a table requirement for the R7 requirement set, which is generally for the exterior applications. And you can see the numbers circled there. The MAHE number that is required has to be to a maximum of 90 for the hazard level 2, or to a maximum of 60 for the hazard level 3. So this is often seen as a key indicator of fire performance for the rail industry and a key requirement to determine whether you can meet the application that you are discussing. Another key requirement that can be sometimes overlooked is, I'm afraid, another acronym, a CFE, critical flux of extinguishment. This is basically looking or determining the degree of spread of flame, how much the flame will spread once the surface catches fire, how quickly that flame spreads through the carriage and across the panels. And you can see again in the table on the right, we have to get above a number on that occasion. We have to get above the number of 20 to meet the requirements for this particular application. Other testing that is done with these standards includes smoke testing. There's a number of other parameters that are tested, and also toxicity testing, which are run through the ISO 5659 standard. A little bit now on the exteriors for rail. We've found from our discussions with our existing project partners that really R7, R8 and R17, those requirement sets within the standard are of main interest to the industry, and that hazard level 2 is generally acceptable at present. That composites on the exterior of trains are quite limited at the moment. There is intention obviously to introduce more composite use on the exteriors, but hazard level 2 will be the acceptable performance. This may be for side panels, maybe for cabs. Looking at a multi-layered system, as I mentioned earlier, you want a decorative system. You want something that has like an automotive finish. So you need a high gloss top coat perhaps, which can be buffable. And we have such a system under test at the moment for these types of applications. Also needs for composite protection for roof coating systems, where maybe the decoration is not required, but you will have other fire requirement properties instead. We've slipped in an extra slide here, actually. It's sort of neither exterior nor interior, but it's referring to some technology we're working on at the moment. And this is related to the powering of rail vehicles, or powering of any transportation vehicles. Is to let you know that we've been working in the area of hydrogen cylinders and also on battery casings. And in this approach we're looking at there, we're not looking so much at fire performance, but more thermal insulation. So we're looking more at how much the temperature can be blocked, how we can prevent a fire event or a heat source from transferring temperature from one side of the material to the other, whether it's pressure vessels or battery casings. But it's just to let you know that we have that also as a set of project work underway in our laboratories at the moment. Moving on to rail interiors, the requirement set R1 is the most common, well-known use and demand within the standard here. And the ultimate target is to get the best you can, get the hazard level 3, get below that magic number of 60 for the MARHE value. R6 also is of interest, so that's railway seats. So we're talking about panels, doors, maybe small items within the rail compartment, table legs, maybe luggage racks, these sort of materials. Also the seats and the flooring. And again, reminding you that our technology will cover both the fire requirements and also decorative and protective requirements in a single step. A little bit more on the seating. So the R6 requirement in the sense of rail. So there we're working to try and simplify processes, at the moment quite complex processes to meet the fire requirements. potentially using glass veils in this sort of application, potentially using multiple coating applications, multiple layers. And lightweighting is obviously a big part, as in the aerospace industry. So we're working with different substrates here and working to meet the requirements for different transport seating. And here we have just one or two numbers for you. We like to share a little bit of data here. A lot of our projects are confidential, so we can't share the whole amount of data that we have, but certainly here we can share some information on this critical parameter, the MARHE number. So we can take an uncoated epoxy glass fiber composite without any fire retardant additives or technology, and that will give us a number of 322. So rather high number for MARHE, so well beyond the hazard level requirements. But if we coat that, in this case we coat that with a two-coat system, we can bring that somewhere just below the threshold of 90 into a hazard level 2 application. So we can make a dramatic difference in the performance of this parameter by putting the two-coat system on this substrate. Alternatively, if you're taking an epoxy glass fiber that already contains some fire retardancy, some fire performance that is meeting a hazard level 2 application, on that occasion, instead of applying a two-coat system, we put a single-coat system on. We don't want to be increasing the fire load with our coating technology. We want to keep it down to a minimum application and still retain the hazard level 2. That provides obviously the decorative and outdoor protective requirements for the application. And as you can see also in combination with the improvements in this MARHE number, we can also reduce the total heat release numbers. So we can reduce the total heat release by adding our coatings onto standard epoxy glass fibers. Looking at an alternative application in terms of interior panels, we've also been working here with different types of materials, sometimes with fully fire retardant boosted polyester glass fiber materials. So on this occasion, we're talking of numbers that are below the 60 number, which is the threshold to get to an HL3, hazard level 3 result. And again, as you can see, if we take our single coat, we can maintain the hazard level 3 performance by applying this onto the that type of substrate. But also we can take a partly fire retardant polyester glass fiber. If you have an uncoated glass fiber system, and this is giving you somewhere in the region of 117 MARHE, then you will be able to, with a two-coat application, you can bring that down into a hazard level 2. So giving you different examples of different types of substrates that we've used and demonstrating with consistent data how we can get to meeting these fire requirements. But we shouldn't overlook the other requirements in the standard, and a very critical one is the flame spread, the critical flux of extinguishment, the CFE number. We've worked on that on many occasions, and as you can see, we've done a considerable amount of testing here with different test labs, and we're consistently above the number 20 for this parameter, demonstrating that we're meeting the requirements for this type of application. The third of those ISO standards was the 5659, so smoke and toxicity applications. Again, we have vast numbers of sets of data, but just sharing one or two with you, demonstrating again that we can meet hazard level 2 or hazard level 3 levels with single coats, with multiple coat systems over different types of substrates, different types of composites. Moving on to infrastructure, a few things in the infrastructure world. We wanted to make the point that there aren't any fixed requirements across Europe. It is very much down to the national network. A lot of those organizations will reach for the, again, the 45545 standard, or alternatively for the harmonized construction product standard, the EN 13501, as a way of referencing materials. Sometimes national standards could also play a part, such as in the UK, the BS 476 standard. Most important thing is to select the most appropriate standard for the application, for where the location is going to be. if it's going to be in near to tunnels or inside tunnels, if it's going to be an open application, and choosing the correct set of fire testing and standards accordingly. What we've done here was the EN 13501 we focused a bit more on, and there we've had some really very encouraging results. With the construction product standard, this is a A to E classification system. In reality, A is only incombustible materials will meet the A classification, so to expect composites to meet the A classification is really not going to be possible in most instances. So we fortunately are able to meet the B classification, so we meet the next best thing, which is the B classification for this standard, which is certainly a lot better than some of the materials that are out in the market at the moment, which could be down at the D or the E classification at the moment. And you can see we meet the B classification very easily. Here we've got a different set of parameters that are being tested, but again, it's flame spread, total heat release. It is in the end looking at how the fire is taking hold, how it is propagating, and how much energy, how much heat is being emitted as it starts burning. Case study on this occasion, we had a project about 18 months ago where we're working with the UK to deliver a fibre reinforced polymer footbridge. I'm pleased to say that the project was very successful, and in fact there are two of these up in the northwest of the UK, meeting all the objectives, including the BS 476 Part 7 to the best result, the Class 1. So this was an important project. Composite footbridges important here because the owner, this was a Lancashire County Council, didn't want to change the structure or the foundations to support the footbridge. So the lightweight nature of the composite footbridge was a really important aspect, as well, of course, as the fire performance required to network rail standards. We mentioned a little earlier some work on thermoplastics. We are still really at the infancy in the early stages of working with different types of thermoplastics. But so far we've got some initial conclusions. We're very happy with the results so far with polyamides, polyamide 6 and polyamide 12. Polycarbonates as well, we can get improvements in fire performance with our coatings on polycarbonates and also polyacrylics. Other thermoplastics are a little more challenging, usually due to their compatibility and the adhesion of our coatings over those materials. And certainly increased market interest, certainly in the railway, road world. You're well aware of the additive manufacturing 3D printing interest, the possibility of making small volume numbers of parts through 3D printing processes using thermoplastics. So certainly we have projects in that area. And also you can see we've got some grad poles that we've been working with one of our project partners. A few more results here. I won't go through these in great detail. On the left-hand side, we have some typical, again, this MAHE number, the maximum average rate of heat emission. So if you recall, we're really trying to get below 90 for it to be significant. And you can see the substrates that come in can be all sorts of numbers. They can be down to 70, but often they're in the several hundreds, as much as 500 possibly. When we're playing with them and we're adding coatings on top of those substrates, we can bring the numbers down again. As you can see, a two-coat system can bring us into hazard level 2, perhaps, or a one-coat system. If we're already at hazard level 3, we can maintain that with a one-coat system. And the polyamide 6 on the right-hand side, that final set of results on the right-hand side, again, reaching a hazard level 2 from an uncoated MAHE number of 192. So very significant improvements in reducing this rate of heat emission and meeting the EN 45545 standard. Okay, I think that's all I'll contribute to at the moment. I'll hand you back to my colleague here, Harry.
Thanks, Trevor. So we will heading to the final part of the presentation. So what's new at the Finlester? Well, we have our own in-house new fire test lab, which means that we can give you great support on your projects and R&D. We will use our in-house expertise in composites, coatings, and fire. That combination is a very unique offering in the composite sector. The capability we have in the fire lab, we have a concalorimeter, We just had our inauguration for Concave Mirror, and her name is Lucy. We have more basic test, UL94, and then we have a incombustibility test, 1182 for IMO Part 1, which is very tough for composites. But we also have an indicative way of doing things and testing things, like a thermal insulation test for various standards, and we have an indicative lab scale flame spread ISO 5658 testing on Part 5. Also, we are planning to have more equipment coming in on end of summer, for smoke and toxicity testing. Well, the question more or less is that, does red work in my composite, in your composite? Well, the short answer is we don't know, but let's test it because it's highly dependent on the substrate, as you saw from the data. So in practice, we are offering this viability study service, meaning that you can send us your composite, you can send us your target requirements. What do you need to pass? Is it EN 45455 or is it something else? So at the beginning, we will do screening. We will check the full compatibility with the basic tests, because adhesion is everything. If there's no adhesion, there's no fire protection. So that needs to be tested first. But if that's okay, we will provide concalorimetry testing and interpretation. We can provide you top quality results, reporting, including photos, videos. We can do thermal insulation and flame spread testing. And after the testing, we can return those coated samples to you that you can test it if the composite is still valid. And of course, we can send you non-burned samples back to you to test if you want. These are the figures and the reporting that we can get from our concalorimeter. So you can get the curves and you get the numbers, and we can talk them through together. What it means, what it means to have a Mare of 898 in 3-coat system, but actually lower Mare in 2-coat system. And then we have an example here that we have a thermal insulation test. This is a 40-minute burn for 900 degrees flame, propane flame, and we measured the temperature from the composite in 1 millimeter depth from the outside and 7 millimeter depth from the outside, from the flame side. And we can see that after 10 minutes, the temperatures stabilize in a composite, which is due to this ceramification effect combined with intumescent thermal protection. And this is very unique in the way that the curves flatline after 10 minutes is not going to meet the outside temperature even if you burned longer. In conclusion, red will complete your standard composite, unlike any other alternative in the market. Our fire test laboratory is ready to run viability studies for you, and flexible and trustworthy solution for tighter fire safety regulations. For the last slide, we have our quarterly webinar, second part coming in 20th of May, where we concentrate on construction. And we have relevant data to show in May. Let's put one more video to show here. The thermal insulation video. And I think that we don't have you have questions. We have questions. Okay.
Yeah, sadly, we have had some issues by not reaching everybody's questions, but we're trying to manage to enable that feature for all. But in the meanwhile, we have a few questions. One of them being, do your products fulfill REACH requirements?
Yes, we have full REACH registration materials in these products, and there's no problem with the REACH registration and the use of the coatings in in the EU.
And we have a question of, can it be used as a gel coat?
Good question. Pure red, the primary intumescent primer can be used as a gel coat. The hybrid red, the top coat, cannot be used as a gel coat. It's a coating, so it's after demolding the part, you can paint it like your car or your furniture. So pure red as a gel coat, hybrid red not is a coat.
Someone would like to know more about anti-graffiti performance.
Anti-graffiti properties, I mean, these are very easy to clean products. The top coat, the hybrid red, is very hydrophobic in the sense that it's going to repel water and it's going to repel dirt. And of course, it's going to repel it's not vandalism proof, nothing is vandalism proof, but it's easy to clean and easy the graffiti is easy to remove. Okay.
One more here that we have been able to receive. Still working on the Q&A enabling. Sorry about for all of those who can't answer or can't ask questions at the moment, but please feel free to send those to the emails visible on the screen. We will answer them later, no problem there. The last question from our end here is there a full range of colors available?
Even the name is red, there are all the colors available. So it means that, like I guess we mentioned that there's a RAL color card that we follow. So all the colors are available in hybrid red, yes.
Yeah, so we've been working with both light colors, maybe the whites for the interiors, obviously for the exterior, for the decorative and protective exterior of trains, you need livery colors. So you have the photos there of a purple color, blue colors. Also in the seating, sometimes a metallic effect, so silver color can be also be achieved with our red technology.
Yeah, and I think we should mention also that it's also possible to make clear coating, lacquers.
Yeah, we have a transparent clear coat that can also give, to a certain extent, the same sort of properties. Yeah. It won't give quite the same amount of fire protection or thermal protection, as it's not going to include part of the technology in that. But certainly we are also working with clear, translucent rather than fully transparent, but translucent technologies.
Correct. Okay. Again, apologies for the Q&A not fully functioning, but of course you can send the questions through our emails or call us. We are happy to answer those questions.
And we'll be sending out a link to the recording of this webinar in the coming days, and of course a copy of the presentation. So please do get in touch and describe to us what you would perhaps like to us to investigate for you as part of our viability study service. And we look forward to welcoming you to the next webinar.
The video in the background is a bit boring. It takes like 40 minutes to finish, so maybe we don't watch that, but you can have a copy if you want. So please contact us. Thank you from our side, and have a nice rest of the week.
Thank you now.
Bye-bye.